when research projects come for review in institutional research committee, most of the time the discussions or the arguments or the suggestions are based on sample size calculation. I know a statistician will give you a correct sample size, but as a researcher, you should know the basic steps of calculating sample size and power. Okay, so this class is on calculating sample size and power. Okay. Right? And you are primarily responsible for your research project. So if there is a very good outcome or there is errors in your result, you are responsible. So I'll explain how to, what is sample size, what is the significance of sample size, how to calculate sample size, and what are the factors that determine a sample size. Okay. Regarding sampling methods, it was already discussed in a previous class. If there is any doubt, please go through that video before starting studying this sample size calculation. So, sample size is how much study items you have to include in your research study. How much samples you have to collect. That is sample size. What will happen if you do a very small samples? If you collect very small sample, too small a sample size, what will happen? Your validity of the study will be affected. Your precision, your accuracy. Regarding validity of study, it was already detailed in a previous class. So, if there is, even if you conduct a study very well, you will not get a correct result if the sample size is too small. And also, even if there is a causal association between an exposure and outcome, you will not get it if you go for a very small sample size. The result will be erroneously interpreted. Okay. And what will happen if you go very large sample size? If you collect more than what you want, what will happen? There will be constraints in time, wastage of time, there will be wastage of money, wastage of energy, wastage of personnel. All this will happen. So, a sample size should be always optimum. That will be between the lower limit and the upper limit. So, optimum. Okay, and you have to calculate an optimum sample size before commencement of the study. Even after, in some cases, you have to go for a post hoc sample size calculation or power estimation after completion of the study. But then, if you find that the results are affected because of the sample size, then the whole thing you have to repeat. So, better you go for an optimum sample size calculation before commencement of the study. Now, I will tell you some of the terms or factors that affect calculation of sample size. Random error. It is the type of error which occurs by chance and can be due to subject differences, sample variability, and also due to measurement errors. So this random error occurs due to chance, and this can be reduced by increasing the sample size. Okay, and systematic errors are because happening due to bias. There can be selection bias, there can be information bias, or there can be confounding, and this can be reduced by increasing the or optimizing the study design. Okay, and precision is what you call the reliability. Okay. That is, on repeated measurement, the tool should give the same result. And actually, precision is a measure of random error, and accuracy, otherwise called the validity. Okay. That is, it is actually a measure of systematic error. All these four was described along with the class on validity of study design. Okay, so you may refer that. I am not going to details. And coming to null hypothesis and alternate hypothesis. The null hypothesis states that there is no association between an effect and outcome, or exposure and outcome. If there is no association between exposure and outcome, that is null hypothesis. Null means zero, there is no association. And alternate hypothesis is the opposite or contradicts the null hypothesis. It states that there is an association between exposure and outcome. It can be either single tail, that is only to one side, or it can be two-sided, either way. Okay, so null hypothesis is there is no association between exposure and outcome, and alternate hypothesis is the opposite of null hypothesis, which states that there is an association between exposure and outcome. And type 1 error is the alpha error. Suppose there is a null hypothesis which is actually true in the population. Null hypothesis that is true. Okay. But the investigator rejects a null hypothesis when it is actually true in the population is called a type 1 or an alpha error. That is a null hypothesis which is true in the population and erroneously the investigator rejects that. That is alpha error. And normally this can happen. So the level of or the proportion of alpha error in a study, we call it as a level of significance. And that is taken as Z alpha, and it is usually taken as 0.05 or 5%. Okay, so an investigator rejecting a null hypothesis when it is actually true in the population is type 1 error or alpha error, and the level of significance usually it is Z alpha, which is 0.05 or 5%. And the sample size is inversely proportional to type 1 error. Okay, so alpha error is inversely proportional to sample size. When the sample size increases, the chance of type 1 error decreases. It is inversely proportional. Okay, so now you know what is an alpha error or a type 1 error. Type 2 errors are otherwise called beta errors. Okay, what is that? When a null hypothesis is false, it has to be rejected. But the investigator failed to reject a null hypothesis when it is false. That is called a beta error or type 2 error. Okay, investigator fails to reject a null hypothesis when it is false is called type 2 error or beta error, and the opposite of this is called power, that is 1 minus beta is the power. And what is that? That is rejecting a null hypothesis when it is false. That is a power, and this power is what a study wants to be. That is to pick up what it is looking for in the population is called the power. So what will happen when the samples, this power is directly proportional to the sample size. When the sample size increases, the power of the study increases. That is to correctly identify the association between exposure and outcome, or correctly identify a relationship between two variables, this power is needed, and when the sample size increases, the power also increases. Okay, and the in the population we call the Z beta is the type 2 error. This effect size, that is the strength of association between two variables in the population. the effect size, that is the strength of association between two variables in the population. So when the effect size increases or effect between two variables increases, it will be easier to pick up in the study. Okay, that is effect size, the strength of association between two variables. When it increases, the probability of finding out or picking up that association also increases. Okay. While talking on sampling methods, I told you about clusters. We make the whole population or the universe into multiple clusters, and this geographic clustering makes the study easier to perform and also low cost to perform a study. So these clusters, sample size in these clusters are determined by previous studies. Okay, and also the variability inside a cluster and between the clusters. Okay, got it? Geographical clustering is used for studies, and we assume the sample size from the previous studies depending upon the variability, number of clusters, and also the variability within the clusters and between the clusters. Okay, and usually that is expressed as a design effect, and this design effect is actual sample size divided by effective sample size. Okay. And this effective sample size is this, if you are, what will you get with the sample size if you do this as a simple random sampling. Okay, so in order to get an actual sample size, you have to multiply the design effect with an effective sample size, that is the sample size you get if you are doing this study using a simple random sampling. So this is design effect, which is used for cluster sampling. Okay, design effect is a constant which is usually between 1 and 2. Okay, 1, or it can be between 1 and 2 is the design effect, usually done for geographical clustering of or cluster sampling. Okay, and another two terms you have to know is, one is an odds ratio and another one is relative risk. This I already explained. Odds ratio in case of case control study, and by using a 2 into 2 table, how to calculate this odds ratio and relative risk. I have already explained odds ratio for case control study and relative risk for cohort studies. Both are already explained in previous classes. The next important thing is power analysis. Okay, you know what is a power. It is 1 by 1 minus beta, and the power of a study is the ability to pick the correct or ability to pick what it is intended to. If a study want to find out an association between exposure and outcome, if it is a very good power, then it will correctly pick up the association between exposure and outcome. So that is power. Now you are familiar with the factors which mainly affect or help in determining the sample size. And when will you go for a sample size estimation? At what stage of the study will you go for a sample size estimation? As I already told, it is always better to calculate the sample size before commencing the study, that is at the time of planning of the study. And also, if you have not able to include the sample size during the study, you can also go for a post hoc power analysis after completion of the study. That is, if after completion of the study you cannot get any significant association between the variables, but you are not able to include the sample size needed for the study, you can go for a post-hoc power analysis after completion of the study. I already told power is 1 minus beta, that is the ability of a study to pick up what it is actually looking for in a population. So the thing is, you have to remember that always it is better to calculate the sample size before planning or before starting a study, that is at the planning stage of the study. Okay, so that is important. And this sample size will vary depending upon your study design and the primary outcome measure. Okay. That means this sample size is depending upon your research question and also it depends upon the primary objective. Okay, so the study design, if you are looking for estimating the mean, there is a formula for sample size estimation. If you are looking for a proportion, again the formula for sample size is different. And for analytical studies, if you want to compare the effect of two variable, again the formula for sample size varies. That is, it varies with study design and also according to your research question and what you are intending to measure as a primary outcome measure. Then also the sample size varies. That means your sample size depends upon the study design and your primary outcome measure. That is why you should not think that always the formula for sample size calculation is 4PQ by D. Don't think like that. It will vary depending upon the study design, whether it is an cohort study, whether it is a case control study, whether it is a clinical trial, or you are doing a cross-sectional study. This sample size formula, sample size calculation formula will vary. Okay, and also there are different approaches for estimating the statistical inferences. And for example, if you are looking for an estimation, it is usually confidence interval approach. Okay, confidence interval approach. And if you are going with an hypothesis testing, you are finding out whether it is the null hypothesis or alternate hypothesis. Hypothesis testing. It is the test of significance approach. Okay. Test of significance approach. That is, the test of significance are like chi-square test, t-test, z-test, finding the p-value, etc. So, by all these means, so a researcher should know in which all conditions, which are the formulas and methods to find out sample size. So, now you decided your study design, you went through the research question and also your primary objective. You took into consideration all this, the null hypothesis, alternate hypothesis if needed. Then the hypothesis testing, mind you, our hypothesis testing is happening only in analytical study. There is no hypothesis testing in case of descriptive studies. Okay, so you did all that, you looked into additional parameters like alpha error, beta error, power, effect size, design, precision, accuracy, for all that. Now you can calculate the sample size by doing 4 methods. One is using formula. Okay, and the second is by preformed tables. And the third is by using normograms. And the fourth is by computer generated softwares. There are so many free softwares also. By using formulas for calculating the sample size, you have to take into consideration the mainly 3 factors. One is an estimated prevalence of the variable of interest. residents might have asked in the research committee meeting sessions that what is your P? Tell me from where you got your P. This is it. That is the estimated prevalence of the variable of interest. And in a formula of 4 PQ by D, again this P is important. You can take the P from your pilot studies or from after literature review. If you find out previous studies of similar nature, you can take it from there. And if you cannot get an estimate of previous value, you can take this P as 50%. 50 you can. Okay, so that is P. And you have to remember that if your research question is looking for the proportion of certain variables in the population, you have to take the P of proportion only. You have to go for previous studies which shows the proportions. If you are finding out research question is finding out an correlation or an association of certain variables, you cannot take the P of prevalence or the proportion from previous studies. That you have to remember. Okay, so one is an estimated prevalence of the variable of interest. Second is desired level of confidence, that is it. That is usually taken as 95%, and it is a constant at 1.96. Okay, and the margin of error also you have to decide at what accuracy you have to compare your proposed result with those already prevailing in the population or with the gold standard. So that is usually this margin of error is taken from 0.01 to 0.05. Okay, usually we take this as 0.05, right? So, and what is this Q? Q is 1 minus P. Okay, so in a formula you have to go through all this desired level of confidence, which is a constant, and also think on the margin of error. So your literature review, the importance of literature review comes in this. From previous studies, if there is no previous study, you better go with a pilot study, and if you cannot do a pilot study and there is no previous studies, you can take it as 50. Okay, this 50 can be taken for this P value, right? The next method is by using ready-made tables. So if you give this estimated prevalence of variable or the desired level of confidence levels, and that from the preformed table you can find out the number of sample size, okay, or the how much samples you want to collect. And also there are nomograms. Either you can take, if you give the study design, the details of the or number of controls, number of details of cases. If you give to that, there are nomograms which give the sample size as arbitrary or as estimated for your particular study. And regarding softwares, these are the softwares available for calculating the sample size, like EpiInfo, and this SPSS is widely used. Now the latest version is version 27, and also EpiInfo and this OpenEpi.com by CDC Atlanta and Biostat MC by Vanderbilt University. These two are free softwares for calculating this sample size. So for any study, first you design your formulate your research question, then decide the study design, look into the primary objective, and also if there is any test of significance and hypothesis testing is needed or not. Then depending upon that, find out the formula which is accurate for your study design and research question. Okay, and even then these formulas will tell only on crude association. It will not look into confounders, if any. So there applies this 10% rule. What is it? As I already told, 10%. Okay, 10% rule. As I already told, this formula, sample size calculation by formula, will give only a crude association between an outcome and exposure and outcome. So this 10% rule is that you can add 10% to the sample size for each confounder you expect. Okay, that will again increase the validity or accuracy or precision of your study. And these are the basics that you should know. And even now, even after studying this, you are confused, you can get the help of a statistician in sample size calculation. And regarding the basic course in biomedical research, you get 1 or 2 MCQs from sample size calculation, especially the formula, basically the set PQ by D square, and you have to apply the values into the formula and get sample size calculation will be an MCQ. And also you should be aware of this softwares which are widely used in sample size calculation. Okay, thank you.